In today's fast-paced digital world, software development teams face relentless pressure to deliver more features, faster, and with higher quality, all while minimizing cost and avoiding burnout. Yet, despite agile frameworks, DevOps pipelines, and sophisticated project management tools, many teams still struggle with delays, bottlenecks, and wasted effort. The reason is deceptively simple. All systems have constraints, the single weakest link that limits performance, no matter how optimized the rest of the process is. In software development, this could be a slow testing process, a critical dependency on one senior engineer, cumbersome approval chains, or poorly structured architecture. The theory of constraints, TOC, pioneered by Dr. Eliyahu M. Goldratt, provides a lens for seeing the invisible bottlenecks that silently throttle productivity. Rather than trying to optimize every part of the system equally, a common trap in software organizations, TOC teaches teams to identify the constraint, focus improvement efforts there, and align the rest of the workflow to maximize overall throughput. Think of a software delivery pipeline as a high-speed train. No matter how fast the front cars move, the speed of the slowest car determines the train's pace. TOC equips leaders, developers, and managers with a methodical approach to locate that slowest car, accelerate it, and create a system where value flows seamlessly from idea to deployment. By embracing TOC, software teams can transform from reactive firefighting units into flow-optimized engines of innovation, capable of delivering consistent, high-quality results while reducing stress, wasted effort, and friction. Core idea. The bottleneck defines the system. At the heart of TOC lies a deceptively simple truth. A system's overall performance is determined by its single most limiting factor, the constraint. In software development, teams often try to optimize every part of their workflow simultaneously, speeding up development, adding more tools, hiring more people, or implementing complex CI/CD pipelines. Yet, the overall throughput rarely improves. Why? Because the system is only as fast as its slowest link. A constraint is any factor that prevents a team from delivering value faster. It may be a slow QA process, a single developer handling critical modules, excessive approvals, or architectural complexity. Recognizing constraints requires observing where work accumulates, stalls, or waits, not just where people are busy. Ignoring the constraint creates the illusion of productivity. Developers may produce features quickly, but delays elsewhere cap actual delivery. TOC teaches that true improvement comes only from focusing on the bottleneck. For example, in a web application team, the QA process might be the constraint. If developers produce features faster than QA can test them, the system's throughput is capped, causing delays, context switching, and frustration. Addressing the constraint transforms the pipeline from stalled to flowing. The 5 focusing steps in software development. The 5 focusing steps of TOC provide a repeatable framework for continuous improvement. Identify the constraint. Observe where work piles up, stalls, or waits. In software, it might be QA, a deployment process, or a critical backend module. The constraint determines the system's maximum throughput. Exploit the constraint. Maximize the constraint's efficiency without major investments. Prioritize critical tasks, remove interruptions, and automate repetitive work. For example, implementing checklists or pair programming in QA can increase output immediately. Subordinate everything else to align upstream and downstream activities to the constraint's capacity. Adjust sprint priorities, limit work in progress, and coordinate team efforts to maintain smooth flow rather than overwhelming the bottleneck. Elevate the constraint. Increase the constraint's capacity through investment. Automate processes, train additional team members, improve architecture, or implement CI/CD pipelines. The goal is to leverage the constraint to unlock system-wide performance. Repeat the process. Once one bottleneck is resolved, another emerges. Continuous improvement becomes cultural. By repeating the cycle, teams achieve iterative, systemic performance gains rather than temporary local optimizations. Key metrics of TOC in software development. TOC emphasizes system-level outcomes, not just activity metrics. Throughput represents the rate at which value is delivered to users. It's not about lines of code or tasks completed, but actual impact in production. Inventory includes all work in progress and partially completed tasks. untested features, code in review, or unmerged pull requests. Excessive inventory creates context switching, delays, and wasted effort. Managing inventory means balancing work with the system's capacity. Operating expense encompasses resources consumed to deliver software, including developer time, tools, infrastructure, and meetings. TOC encourages minimizing operating expense while maximizing throughput, focusing investments on the constraint for greatest impact. Together, these metrics provide a lens for evaluating system performance, enabling informed decisions that optimize flow rather than activity. Software development example. Constraint in a delivery pipeline. Consider a team building a web application with multiple stages: requirements gathering, development, code review, QA, deployment, and release. Developers produce features quickly, but QA has limited capacity and relies on manual testing. Here, QA is the constraint, limiting overall throughput. Applying TOC. Identify. QA is the bottleneck, as features pile up there. Exploit. Prioritize critical tests, reduce interruptions, and automate repetitive tasks. Subordinate. Adjust development pace to QA capacity. Deliver features incrementally. Elevate. Train additional QA engineers, implement automated testing, and improve CI/CD pipelines. Repeat. With QA no longer the constraint, deployment or backend integration may become the next bottleneck. By systematically addressing the constraint, the team transforms delays into opportunities for high-leverage improvement, increasing flow and overall delivery. Integrating TOC with Agile, DevOps, and Lean. TOC complements Agile, DevOps, and Lean by adding strategic focus to tactical practices. Agile emphasizes iterative, customer-focused delivery, but without identifying constraints, teams risk local optimizations that do not improve overall flow. DevOps focuses on automation and operations, but bottlenecks in QA, code review, or architecture can still slow delivery. Lean reduces waste, but applying it to non-critical areas has minimal impact. TOC aligns these practices by identifying where flow is limited and focusing improvement there. Teams shift from reactive workflows to system-level optimization, where every decision, investment, and process change supports smooth value delivery. TOC as a leadership mindset. TOC transforms leadership from task management into system orchestration. Leaders focus on flow, not busyness, and view constraints as leverage points rather than problems. Proactive TOC leadership involves continuously observing workflow, identifying bottlenecks, and strategically allocating resources. Subordinating non-constraint work, investing in constraint capacity, and fostering continuous improvement create a collaborative, high-performing culture. This mindset reduces blame, encourages innovation, and aligns teams around maximizing value delivery, turning software pipelines into predictable, high-throughput systems. Summary and takeaways. The theory of constraints provides software teams with a clear framework for systemic improvement. Key takeaways include: focus on throughput, not just activity. Identify hidden constraints that limit system performance. Apply the 5 focusing steps to maximize, align, and elevate the constraint. Integrate TOC with Agile, DevOps, and Lean to enhance flow and reduce waste. Embrace a leadership mindset that prioritizes systemic value over individual effort. By treating constraints as leverage points, teams achieve faster delivery, higher quality, reduced stress, and more predictable outcomes. Call to action. The theory of constraints isn't just a methodology, it's a practical approach to transforming software delivery. Start by mapping your workflows, identifying where work stalls, and applying the 5 focusing steps. Small, deliberate improvements at the constraint yield outsized impact across the system. Empower your team to shift from reactive firefighting to proactive flow optimization, and watch how bottlenecks become opportunities for innovation and growth. Begin your first cycle today. Identify your constraint, align your team, and elevate the bottleneck. Each iteration brings your software delivery closer to smooth, high-performing, value-driven flow.